Welcome to the DIY Honda Garage channel. In this presentation, we will diagnose DTC P0716, which indicates a problem in the input shaft speed sensor circuit, specifically for the 2008 to 2012 Honda Accord. This trouble code suggests that there is an electrical issue related to the signal that the input shaft, also called the main shaft, speed sensor sends to the engine control module, ECM. This sensor is crucial as it provides data regarding the rotational speed of the input shaft, which helps the transmission control unit to manage gear shifts effectively. Problems with this sensor can lead to inconsistent shifting and can result in poor vehicle performance. We'll also touch upon related DTC P0721, which involves the output shaft speed sensor circuit. DTC P0716, however, is primarily indicative of an electrical circuit problem and not due to mechanical failures within the transmission system. Key steps will involve utilizing the Honda Diagnostic System, HDS, checking the connections, and ensuring that the vehicle's onboard diagnostics are fully reviewed before any physical inspections. The input shaft speed sensor plays a pivotal role in a vehicle's transmission system. Located on the transmission assembly, this sensor detects the rotational speed of the input shaft and sends this information to the transmission control unit. In the context of DTC P0716, the primary concern is an electrical circuit malfunction, rather than a failure of the sensor itself or any mechanical issues. The sensor is generally situated on the transmission housing and is connected through a series of electrical connectors. It's essential that these connections are intact and not subject to corrosion or damage, as this can disrupt signal transmission and lead to erroneous readings. Furthermore, it's important to understand that this DTC indicates an electrical issue, and troubleshooting must start with the electrical circuits rather than diving into mechanical inspections of the transmission itself. The causes of DTC P0716 can be traced to several key issues in the vehicle's electrical system. A poor electrical connection is one of the most common culprits, which could range from corrosion at the connector pins to loose wiring. Such connections are critical as they can interrupt the flow of information between the sensor and the control module. Another potential cause is a faulty input shaft speed sensor itself, although this is less common since the issue usually lies within the connection or wiring. Additionally, wire harness issues, such as fraying or breaking due to wear and tear or environmental factors, can lead to an open circuit, causing the signal to be interrupted. Diagnosing these issues requires careful inspection of all related wiring and connections to ensure reliable readings from the speed sensor. Symptoms associated with DTC P0716 can significantly impact the overall performance of the vehicle. Drivers may experience inconsistent shifting patterns, where the transmission hesitates or shifts abruptly, resulting in a less smooth driving experience. This inconsistency arises because the transmission relies on accurate speed data from the input shaft sensor to determine when to shift gears. Additionally, poor vehicle performance can manifest as reduced acceleration or overall sluggishness, making the drive feel less responsive. The check engine light on the dashboard will typically illuminate, alerting the driver that there is an ongoing issue that requires attention. It's essential for the driver to pay heed to these symptoms, as they can lead to further mechanical complications if left unaddressed. The first step in troubleshooting DTC P0716 involves ensuring that the ignition switch is turned to the on second position. This is critical as it powers up the vehicle's electrical systems without starting the engine. Then, utilizing the Honda Diagnostic System, or HDS, clear the trouble code to reset the system, allowing for a fresh set of readings during testing. Following this, the vehicle must be prepared for testing by either securely supporting it and allowing the front wheels to rotate freely, or placing it on a vehicle lift. This preparation is necessary for conducting a test drive while monitoring the vehicle's performance under specific conditions that can help replicate the issues indicated by the DTC. The second step requires the application of safety measures. Block the rear wheels to prevent any movement and ensure safety during testing. Once secured, start the vehicle's engine while disabling the Vehicle Stability Assist (VSA) system by pressing the VSA off button. The reason to disable VSA is that it could interfere with the vehicle's dynamics during the diagnostic tests, potentially skewing results. Shift the gear lever into the D position and accelerate the vehicle to a speed exceeding 12 miles per hour, which is roughly equivalent to 20 kilometers per hour. Maintain this speed for at least 10 seconds. This action will allow the speed sensors to adequately send data regarding wheel and shaft speeds to the control module for observation. After completing the initial driving test, it's essential to check for any pending DTCs using the HDS. The presence of either DTC P0718 or P0723 indicates additional speed sensor issues that may require focused troubleshooting. These specific codes pertain to the input and output shaft speed sensors, respectively, and if either code is triggered, one must follow the related troubleshooting steps for those specific DTCs. However, if neither of these DTCs is indicated, proceed to Step 6 of the troubleshooting process. This step helps to determine whether the issues are isolated to P0716 or whether other transmission error codes may also need attention. In this step, checking for additional pending DTCs is essential to analyzing the transmission system further. Using the HDS once again, verify whether DTC P0716 or P0721 appears in the system. If either code is present, this indicates continued issues with the input or output shaft speed sensors, and one must proceed to Step 7 for a more targeted inspection. On the contrary, if no codes appear, this might suggest an intermittent failure of the system where the components are functioning correctly at that time, pointing to possible transient electrical issues that may need further observation. Completing this check is crucial as it clarifies whether ongoing issues remain or if the trouble was temporary. Step 7 drives the technician to check both the input shaft, main shaft, speed sensor, and the output shaft, counter shaft, speed sensor. Begin by inspecting the connections at each sensor for any signs of poor installation or corrosion, which can lead to poor electrical contact. A good connection is vital for accurate sensor readings. If these connections appear compromised, they should be cleaned or tightened as necessary. Next, verify the installation integrity. Poor installation could stem from improper alignment during previous repairs. If there are issues found in this area, the connectors should be reattached securely. If the connections and installations check out, the next course of action would be to replace the respective faulty speed sensor. Following this, technicians should proceed to Step 8. Having addressed the sensor connections or replace the sensor if necessary, the next step requires turning the ignition switch back to the on-to position. This again powers the vehicle's electrical systems, enabling the HDS to engage with the vehicle's onboard diagnostic systems. Clear DTCs once again using the HDS, as this sets a clean slate for further testing to ensure that any previous codes that may have been triggered are no longer affecting system performance. After clearing the codes, it is crucial to prepare the vehicle for another cycle of testing by ensuring it is operating under the same conditions as in prior tests. This will help ensure that any issues are accurately diagnosed and do not persist unnoticed. After performing the clear DTC procedure, start the engine again. Disable the VSA by pressing the VSA off button, just as done in previous tests. Shift into D and accelerate the vehicle to maintain speeds surpassing 12 miles per hour for another period of at least 10 seconds. During this driving and testing phase, consistently employ the HDS to monitor for any pending or confirmed DTCs. After completing this cycle, the concrete action is over. Check to see whether DTC P0716 or P0721 is still indicated in the system. If either code is still active, it indicates that the circuit issue has not been resolved, and one must return to the earlier troubleshooting steps. Conversely, if no codes reappear, it signifies that the system is functioning correctly, thus completing the troubleshooting process successfully. In the final repair verification stage, it is critical to confirm that no DTCs remain after completing all necessary repairs or adjustments. Utilize the HDS to scan the system thoroughly, ensuring that it does not indicate any residual error codes connected to the speed sensor circuits. Next, perform a thorough test drive under varying driving conditions to confirm that the vehicle operates normally, with smooth shifts and no performance inconsistencies. Pay careful attention to how the transmission reacts to acceleration and deceleration, as these are the primary indicators of sensor system effectiveness. If everything checks out, this will validate both the correctness of the repairs executed and confirm that the vehicle is back in optimal working order. Preventive maintenance plays a vital role in ensuring longevity and reliability concerning speed sensor circuits in the 2008 to 2012 Honda Accord. Regularly scheduled checks on electrical connectors can prevent the buildup of corrosion, which is a common source of faults in sensor circuits. It's also advisable to monitor for symptoms associated with speed sensor failures, including unexpected shifting behavior or warning lights on the dashboard. Keeping a close eye on these indicators can lead to early detection and solve issues before they escalate into larger problems. Additionally, maintaining the overall electrical health of the vehicle, including checking battery voltage and condition, will improve the reliability of all electrical components associated with the transmission and other vehicle systems. In conclusion, understanding the roles of the input shaft speed sensor and its related components, along with recognizing symptoms indicative of failure, are essential for effective troubleshooting of DTC P0716. Following a systematic approach ensures that each potential cause is evaluated thoroughly, which protects the integrity and performance of the vehicle. Remember to leverage the Honda diagnostic system effectively throughout the process, as it provides critical insights into the vehicle's condition. Moreover, the importance of preventive maintenance cannot be overstated, as it can help avoid issues before they arise, thereby maintaining vehicle performance and reliability for years to come. Through diligent attention to electrical connections and systematic diagnostic processes, drivers can ensure their Honda Accord operates at its best. Please like and subscribe to the channel. See you next time.